I want to start with a story, one that I heard a couple of years ago at meetings that I went to on hydraulic fracturing. The discussion turned to, well, if we got rid of the leases, we'd be all right. And the way to get rid of the leases is for the people who got signing bonuses to simply give the bonuses back, and that would end it. I want to relate a story that I think has the best answer that I've heard, and it really bears on what we're doing. One of the organizers said, I've just talked to a man, a father, who had just got his signing bonus check. And the father said, I've been able to take my children to the dentist for the first time in their lives. That lays out a dimension of what we're dealing with. I'd like to thank the League for inviting me here. I am a retired physics professor up at Ithaca College. I will assure you that nothing I say has anything to do with physics, sort of. I think the only connection is that by training physicists, and there are a few in the room, look at numbers and ask, what's the story here? What's the story that these numbers are telling? And that's what I'm going to try and do. There's our Marcellus shale, the picture that we've seen. First thing I'm going to look at is income from the Marcellus shale and income from the other things that require clean water, and we'll compare those. I'm going to do a couple of things along the way, and I'll point them out when they happen, as I would like to try and shift the focus a little bit. I'll let you know what that shift will be when I get to that point. But there's the data that I used. About 50 trillion cubic feet, that was an estimate that came out. About a quarter of it's in New York State. The market value currently is about $4 a thousand cubic feet in this country. In Europe, it's 10. That's an important distinction, because the number that is quoted is you need to have 7 or 8 in order to make money drilling, or the horizontal fracturing. I looked only at the royalties, and I picked a 12.5%, and I'll talk about that in a minute. I picked a 20-year lifetime because that's what seemed to be in the literature. In a sense, that scales because all of the numbers were multiplied, the yearly value, by 20 to get it. And I get a projected income of about $6.6 billion. When I first did this graph about 2 years ago, the price was then about $14 a thousand cubic feet, and so the number that I posted then was a whole lot bigger than it is now. Let's back up. Tourism is important in the state, and freshwater attracts it. I asked about $27 billion over 20 years, and by the way, I have some references if people would like them. I have a limited number, and I'll make them available for people afterwards, and if you'd like, you can contact me and find out where these numbers come from. About $27 billion over 20 years, and this is for tourism. Grapes and winemaking, about $68 billion over 20 years. Those of you in the back, I apologize, the bottom's a little low, but you'll begin to see on the right-hand side the bar graph growing as to the income that we are currently receiving that depends on clean water. Farm cash receipts, about $48 billion over 20 years. Dairy, different, and I think it is different in the way they're reported, about $39 billion over 20 years, and the bar graph grows. Hunting and fishing in the Marcellus counties. These numbers, by the way, are only for the counties under which Marcellus shale lies, not the whole state, just the Marcellus shale counties. Hunting and fishing estimated at $40 billion over 20 years. Wildlife watching, about $32 billion over 20 years. That was a number that really surprised me. Are there other things that come out of the need for clean water? Sure. But when I looked at this graph, I said, I think I know something. I think I know something. The projected gas income was about $6.6 billion. It used to be 20 when the price was up. 3% of that current income is $8 billion. A loss of 3% in the current income would wipe out the projected income from royalties on natural gas. There are some things I've been left out, and so I want to be very clear about it. I've left off signing bonuses. Well, the reason I left them out is I haven't any clue what they are. I know people who got $30 an acre way back when. And I know of people who got $3,000 an acre. I have no idea what the signing bonuses really are. There are taxes to local communities that don't have that number either. Increase in potential local jobs. We'll come back to that in a minute. That I think I have some information on. Quality of life, improve or not? That's an open question. On the current income side, I left out the value of clean drinking water. One way I thought of doing it was to use New York City's estimate of the cost to filter their water if fracturing was allowed in those counties, and then get that on a per gallon basis, but I thought, no, that's a little bit iffy. Clean water from other sources. There are other things that depend upon clean water. The Ommegang Brewery over here decided that they were opposed to hydraulic fracturing because of the threat to their water supply they need for their beer. Quality of life can go either way. From where I think the story these numbers are telling is it's unlikely that what's been left out would make these two bar graphs comparable. The risk remains. Small changes in current income from loss of potable water could seriously damage the income, remove the income from gas drilling. Well, what about jobs? This one comes from an Energy West, Headwaters Economics out in Bozeman, Montana. They looked at jobs in what they call two energy-focusing counties, ones that produce coal, oil, and natural gas. Those are the yellow ones. The blue ones are similar ones. There are 26 energy-focusing counties and 254 similar ones. And they compared these two. And this is what they found. In the energy-focusing counties, those that had income from coal mining, oil wells, natural gas wells, there was less economic diversity and resilience. The levels of education in the workforce were lower. There was a greater gap between high and low-income households, a growing wage disparity between energy-related workers and all other workers, and less ability to attract investment in retirement dollars. That's what they found on a 1970 to 2005 study of those counties out west. There's the boom-bust cycle that Professor Christopherson referred to as it occurred out there from 1970 to 2005. You see the solid blue line is the gas-related companies. You see it rise and then fall. There was another energy boom, as it were, in the 1900s to 2000, but it didn't come back out there. You'll notice that the blue line is below the dotted line. The dotted line is from those counties which did not depend upon extraction of gas, coal, and oil. If you look at the growth in income from those counties which don't depend upon that extraction process and those that do, you find that those counties, the non-energy focusing ones, the blue one on top, is their the growth of income, and it starts out that they make more income per person than per capita than the other the drilling counties, and that gap grows. It starts at about $700 and ends up at about $1,800 at the end of the study. Well, that's for oil, gas, and coal out west. What about around here? I've turned to a study by Dr. Jeanette Barth, of J.M. Barth Associates. The title is entitled Unanswered Questions About the Economic Impact of Gas Drilling in the Marcellus Shale. Don't jump to conclusions. And it came out fairly recently. And there's what she found. The blue colors are the gas drilling counties, 10 gas drilling counties out west. These are the vertical wells, not hydraulic, the horizontal hydraulic fracturing. And there are 5 neighbors. And there are the measures of income that she used. She looked at the left, the percentage below poverty, below the poverty line, and they're about the same. The next is the percent unemployment. They're about the same. The gas drilling companies, in fact, had a little slightly higher unemployment. The third bar graphs are the median income in the gas drilling and non-gas drilling counties, and they're virtually the same. The last column is, the last bars are the per capita income, and the gas drilling counties are slightly higher in per capita, but essentially the same. What the study, the numbers I think say is that in western New York, the drilling did not produce an increase in the income of people who live there. Well, what about Pennsylvania, where there is fracturing going on, has been for some years? This study, this also comes from Dr. Barth's work. She looked at the oil and gas employment, and the maximum value, a number of people employed in the year of 2004 was about 2,700 in people in Pennsylvania who were employed. In 2010, there were almost 49,000 people employed by Walmart and about 400,000 people employed in the tourist industry. There were more jobs created in Pennsylvania. I think she used the census numbers here, but not a lot. This is a shift I want to make. I want to move from jobs and dollars to valuing things on other measures. And of the measure I want to use is water. What kind of water use will come with drilling? And what else could we do with that water? What is its value beyond producing natural gas? So it's competition. There is uses for water. Some of them return the water to the hydrological cycle. This is something which sort of hit me between the eyes about a month and a half ago. Tourism, hunting and fishing, agriculture, homeowners and businesses. We use water, it goes through some kind of a process, whether it's a treatment plant or it just flows downstream and goes and plants and sort it out. The water is not removed from the hydrological cycle. And that's what I've been thinking about. And all of a sudden it occurred to me that with fracking, it is removed from the hydrological cycle, and we'll get back to that. It's water that is taken out, and we'll see it turns out to be a lot of water. Ballpark, it takes about 5 million gallons of clean water to fracture a well. Some, perhaps 20% of it, returns quickly to the surface, and it's contaminated, and some, perhaps 80%, remains underground forever. Say the drilling companies. That's when they tell us that there's no way that fracturing, which takes place thousands of feet underground, could ever affect drinking water. What they're saying is that water stays there forever. It's another way of looking at what they're saying. I'm going to use this 20-80% ratio in the examples I'm working with. The numbers, these are estimates. This whole thing are estimates. But these numbers of estimates, I've seen reports where the claims no water returns, and reports where the claim is half of it returns. These are the numbers which I've seen fairly recently. If it takes 5 million gallons of water to fracture a well, what else could we do with it? We could satisfy Ithaca's fresh water needs for 2 days. We're about 3.3 million gallons a day. We could produce grapes for 14,000 bottles of wine. We could produce 3,000 gallons of milk, 2,000 bushels of corn, or about 22 tons of wheat. Those are other things we could do with 5 million gallons. That's a lot of water, yes? That's just one well. That's just one well. Here are some examples of contaminants, and let me just check, because I just want to make sure I didn't jump things here too quickly. That's good. Added chemicals to aid the fracturing process, typically ethylene glycol. Returned material from the drilling process includes heavy metals, includes radioactive metals, but it also includes salt. And I've used, salt, and we'll look at some numbers and see what happens. If 20% returns, that's that number, the estimate I'm using, we're talking about 1 million gallons of water for every well that's fractured. And I'll use that number to work my way through these estimates. They are estimates. I think if we change that number, and I'm not sure what the better one to use, it won't change the end result a whole lot. Typically, return 6,000 parts per million ethylene glycol and 10,000 parts per million of salts of various kinds. EPA drinking water standards, ethylene glycol are 14 parts per million. New Hampshire says 7. Okay, EPA says 14. 600 divided by 14 is about 43. Means we've got to dilute that 1 million gallons by 43-fold in order to make it meet the EPA standard. That's 43 million gallons of fresh water, 8 times the amount that was used to fracture the well to begin with. At 10,000 parts per million of salt, the drinking water standard is about 100 parts per million, so we have to dilute this by a factor of 100. That 1 million gallons that comes back, an estimate, would require 100 million gallons of fresh water to make it meet the standards, 20 times the amount to fracture the well, and that's just one well. Dilution is not a solution to this pollution. There are projected 4,000 wells in Tompkins County, each requiring an average of 5 million gallons. That's 20 billion gallons of water to frack Tompkins County. This comes from the Ithaca Tompkins County Transport, and one of the numbers that caught my attention since I live out near Richford is the projection of truck traffic. They estimate truck traffic down various roads, and they've estimated the truck traffic down Route 79, which goes through downtown Richford. An increase of 6,000 trucks per day. That's 4 trucks a minute. That sounds outrageous. But if you listen to people who've been down and into Pennsylvania where the fracking is going on, they report a truck going by every 10 to 20 seconds. The number sounds outrageous, but unfortunately. Well, what else could you do with 20 billion gallons of clean water in Tompkins County? We could supply the city of Ithaca for 18 years. We could create a lake 1 mile on a side. That's about the size of downtown Ithaca, 106 feet deep. It's a lot of water. That's just Tompkins County. We could produce 3.2 million bushels of corn. What I'm doing is suggesting, rather than dollars and jobs, as important as they are, we look at other costs and see what those costs are, and they're a different measure, and I think it sheds a different light on things. Clean water can be used for a number of things. We make choices about which to use. There are other non-fossil fuel energy sources. And here's one of the things that caught my attention, and maybe it'll catch yours too. Put at the top of the list, conservation. And as I thought about this, it occurs to me that conservation produces energy whose production costs have already been paid. Now, that sounds strange. Now, let's suppose that each of you out there, and I would love to do this, could save 100 gallons of gasoline in a year's time. That's good, right? That's $400. But that's gasoline that's already produced. That's gasoline, the cost to the environment has already been paid. That's gasoline, the dollars costs have already been paid. It's sitting there in the tank for somebody else to use. Conservation produces energy. A strange point of view, but I think it's one that can be helpful as we think about how we're going to deal with our circumstances. And then, of course, there's the standards: solar, wind, hydroelectric. tidal, and more. There are other non-energy producing, non-fossil fuel sources of energy. For example, electricity from the renewable resources. There's a map of the United States. The dark green are those states which can produce 100% or more of the energy that the electricity they use from renewable resources. And when I mean more than 100%, I mean like Minnesota's 1,000%. I mean, we're talking significantly more. Even New York State, cloudy Ithaca, we could produce 80% of the electrical energy we need from renewable resources. Trivial? No. Doable? I think it raises some interesting questions. In making choices, dollars can help inform our thinking. However, I think the underlying issue, and this isn't unique to me, this I picked up from reading somebody else, the question is, what do we value? What do we think most important? How do we deal with the costs of the choices we make? And that brings me back to that father who said, with his signing bonus, now I can take my children to the dentist for the first time in their lives. Thank you.